Okay, so on to hazard modeling or the failure rate analysis I was talking about, that's really what I find the most interesting. And with training in statistics, this is where the action is for me. One of the important questions I think is, is this a progressive problem? Have we seen all, if you haven't seen a problem yet, do you expect that you're going to be able to see a problem in the future? That's really a really important question for forecasting claims and incidents. I mean, if everyone who's going to have a problem has already shown up, it's a totally different ball game to the problem is, what if you have like half of the sheets of drywall in your home have a problem, it just takes longer for the problems to manifest, and they're going to show up in 5 years' time. That's a totally different story. It's an important question for us to pick up with hazard modeling or a hazard model. So what are some of the questions what are some of the risk factors we want to try and identify? Obviously one of the most important there is the sulfur composition, and we've seen a lot of evidence on that, on sulfur composition. We know it's high for some Chinese drywall. The problem is you have to, without destroying the home, can you really get a handle on that? Ideally what you want is a risk model that takes some of the data you get from some of these inspection protocols, and that can use that to provide indicators of failure risk. The most important thing if you're doing hazard modeling, one of the most important things is to design the study right, and that's the sample design, how you do the random sampling, and making sure you have enough information to have statistically significant results. These are some charts from the Garland Green study that came out just a week or so ago. One of the things that I think is interesting here is if you look at the sulfur content of the Chinese drywall board, some of it's high, some of it's low. Just to make the point that this is not homogeneous. There are all Chinese drywall isn't equal, and what it means is that risk modeling is going to be more challenging because of that. So here's one of the pictorial representation of the 50 or 51 sample CPSC study, which I think I've been told has been completed, but it just hasn't been the results haven't been released yet. This is a sort of case control study. It's exactly the sort of study you'd like to be able to make statistical inference about failure rates. Unfortunately, what I think is going to be too small to probably answer any of the questions we really care about, and I want to give you an example why. They have 35 affected homes, 15 unaffected homes. If you use the literature from clinical trials, which are about designing how big a clinical trial has to be to test whether a drug's effective, you can actually compute for this particular sample structure that you would need whatever risk factor you want to measure. If it only affected homes and didn't show up in any homes that were unaffected, so it was a sort of completely precise risk measure that was only ever showed up in affected homes, you'd need 11 homes to be affected for a sample this size to give you a statistically significant result. Now, that's already saying quite a lot, because it's going to rule out a lot of risk factors that you might want to look at, because 11 out of 35 is almost a third. So if you've got any risk factor that doesn't even really show up, more often than that, and you really aren't going to be able to say anything, and that's in the best case. What if you have one of the homes that's unaffected shows up with the risk factor? Now, to show a statistically significant result, you're going to have 16 homes showing up in the affected group. And that equates at the bottom there to a relative risk of 7. So in other words, it has to be a really strong effect for a sample that's a study this size to really give you a measurement.